Hey everybody, Brian here from quantlabs.net. Howdy doody. I wanted to show CMake for probably what's going to be a few projects I'll be working on in C++ for trading projects. Namely, the first one will be for my architecture for a potential, I won't say a pure HFT type of system, but HFT potential, HFT-like type of system. And when I say it's not full HFT, because it's not going to be capable of pure, like the absolute fastest multi-threading, and probably even with Redis as well. But I just want to give you a little backstory. If you come into my YouTube channel and you come under here under playlists, you'll want to look for this wonderful world of C++ for trading, or wonderful, should be world of, but I'm pretty well the world's worst typist. And there's going to be a number of videos here, and this video playlist is exactly for the purpose of how I'm logging my C++ for trading systems. So in there you're going to find probably towards the bottom two videos here. The project that I was referring to is this demo of C++, Redis, NoSQL, Intel, TBB, concurrency together. This video is important because this is what I'm going to hopefully use as my roadmap and blueprint for future trading systems. As you can tell, it will include what I consider the world's fastest database. As far as I know, I've talked about this numerous times, 1.2 million transactions per second. With a Redis cluster. It is NoSQL and it's open source. And of course, there's Intel TBB threading building blocks for multi-currency as well. So I've got these two together, and I'm going to use this project. I'm going to show you on my system here on a Mac, show you how it's built using CMake. So that's the project that I'm going to use. Now, when you come into my blog, all you got to do is just search for CMake on my blog here at quantlabs.net/blog. Look for CMake, and you're going to see obviously numerous postings here. Now, this one's an interesting one because C-Line is a, I don't call it a popular IDE, but it is a C++ IDE for cross-platform development using CMake. So you could use CMake as your preferred IDE or integrated development environment, but there's numerous other ones you could use for whatever operating system you want to use. So let's talk about CMake a little bit, but specifically if you come into, again, this wonderful supposedly world of C++, in there you'll also find another video on called working demo, C++ demo of CMake to Apple Xcode. That's my, looks like it's going to be my preferred IDE. And obviously you can target it for other IDEs. I'm going to show you how to do that. So Xcode's the one for C++ development on Mac OS 10 or Mac OS. And there's obviously other IDEs, including for Windows, Visual Studio. CMake, as far as I know, is supported through Visual Studio through a plugin. And there's going to be also numerous other IDEs you can use, like Kdevelop, CodeLight, Eclipse, and numerous others. So I'm going to show you a tutorial on how to create, to convert your CMake project from the CMake folder that I'm going to show you, and how you can target it for your preferred IDE. So you want to check out this video to get a backstory or the historical on what CMake is. And there's a tool there that you can download. You can watch in this video that will show you how to use that tool, which is GUI based, to create your projects. Now, in here, this is the video I'm referring to, a C++ demo of CMake to Apple Xcode or whatever other IDE. So before I get to that, let me show you a tutorial here. So if you come into this, actually all you have to do is really go into the description of this YouTube video on YouTube. In there, oh, there's no link to it. In that case, all you gotta do really is look for a video or a posting in my blog called C++ demo of CMake 2 Apple Xcode or other IDE. In there, you're going to find a tutorial, really important. This one from John Lamp at johnlamp.net called CMake tutorial on IDE integration. Okay, so what I'm about to show you is the CMake file project, but what he covers in this tutorial is how to integrate CMake with Visual Studio, Xcode for Mac OS 10 or even iOS if you want, Eclipse, and Kdevelop. These are the two popular IDEs you would use on Linux, so you could choose one of these. Okay, I like CodeLight for Linux, and in here in this video there is a demo how to convert it excuse me, into CodeLight. Boy, my voice is giving out. Sorry about that. All right, so that's the tutorial. So I'll put that in my blog somewhere because this is an important tutorial. But what I will show you is the CMake project. Now, this is the actual TBB Redis, a clean installation of how to use that. I'm going to show you how I compiled everything together. So let me just load up my document, and I'll make this available to my, let me just see if I can load it up here. There we go, that's what I'm looking for, simple as that. Alright, so this is my set of instructions. I've talked about the CMake tutorial. I've talked about this Derek Malloy IE. Oh, let me just show you this one. That's an important one. Okay, so let me pull up this tutorial as well. This tutorial is really good. This will give you an overview of how CMake works. Okay, how all the different lines in the CMake list text file will be used to compile with your C++ compiler, let's say GCC or Visual Studio, and how to link all the files and artifacts together. So in this video, I'm going to hopefully try to walk you through, if you're fairly new to C++, all the different files and the build process of C++, and what's created and the files. Okay, so going back to my Word document, there's a couple of things you need to understand when it comes to C++ coding, and specifically the building process of a C++ either library, which is kind of like a dynamic link library if you're doing it in Windows, or static library in C++, or a static library in C++. And there's some stuff you need to do for the library path, and also the include a header path as well, which I'll talk about here in a little bit. C++ can be kind of wonky, so I'm going to do my best to make sure that this video covers all of this stuff as best as I can. So let's talk about C++ and how it's generated first. This tutorial is excellent because it will walk you through actually the building process from a very basic hello world C++ file. Not only that, it'll also show you how it's built and compiled together, and building the executable. Let's say obviously this one's coming out of Ubuntu Linux, so I always try to get people to move into Ubuntu because it's kind of the easiest when you're working with Python and now obviously C++. So with that in mind, what you're doing is a couple of things you need to do, which when I revisited my C++, there was a lot of confusion on how this worked. So in CMake, let me just show you another, I'll do a lookup here for CMake. And the previous videos I showed you is kind of like a history of how CMake works. But basically what CMake does is they have a utility where you can download an executable program for whatever operating system you are. If you are using Windows, Mac, Linux, all the popular ones, or even if you're doing mobile. And I'm just trying to see where the downloading is. Let's see, there should be a download link here somewhere. Here we go, download. So what we're talking about when we're downloading is this program. Now, obviously you can see there is Unix, Linux versions, Windows. It is open source, and the Mac version as well. So let me show you the Mac version. I've shown this before in the previous video. Here's a CMake executable. What you can do is you can select your source folder. In my case, we got a TBB Redis folder. You would have a build subdirectory under that folder, and from there what you would do is configure it and generate, if you want, files for your specific IDE. So in this case, you can use, let's see, I've already done this on the previous video, so you're better off to kind of watch that. So what we have here is, let me show you the structure. So we're in the folder right here in the TBB Redis, and when you navigate into it, what you'll find here is you've got the CMake list text file, we've got the build folder, we've got the include folder, we've got the libraries, and then we have the source code. So the idea here is, if you go into my document here, what we're doing is, let's say in this example, the TBB Redis example, which is that architecture. Now, let's not worry about the source code itself, but we're just going to show you how the CMake works using this project. What we want to do is, there is the Hi Redis or Redis Client for Redis. Now, there's three libraries that you need, or dependencies you need to worry about. There's the Hi Redis C library, which is Hi Redis, and you need to build that locally on your system. If you go to this GitHub, that will show you have instruction how to do that. You have here libev, where you can, if you are going to use Ubuntu Linux, you can go to this link here and learn how to build the library from source here. And then there's the Redis, which is the C++ client for Redis. This took a while to set up. It's just, if you watch my videos on Redis and any of the other videos I've listed already in this video, you'll understand the complexity of getting that Redis or any Redis C++ client working. It is not a fun process. But I managed to get it working for C++. It's the first time I've done it as of last week. And as I said, this library here, the dependencies are to build this library is this one, libev and Hi Redis, which is a C client for Redis. And then here, this link will show you how to build Redis as well, the library. And obviously no different than C#, because you're working with a compiled language now in C++ versus, let's say, a scripting language like Scala or Python. You're never really worrying about the release or debug mode, but when you come into compiled languages, you have to worry about release and debug modes, which is part of your IDE will have that. So that's for the Redis and the Hi Redis library. And then you need to worry about the TBB, which you can download here, and in that will automatically download your Intel TBB library. And again, these videos will walk you through that process. This one specifically, and this one as well, will walk you through that on all these libraries I'm talking about, Redis and the Intel TBB. Okay, so watch those for more detail, more history on how those work and how you build them. Then we get into my code. You can see how complex the libraries can be. It's a fun process. That's why I would consider C++ not to be a fun language, but when you're working for high-speed systems, the pain up front is tough, but once you understand it and understand how libraries and other coding projects work with something like CMake, it does get much easier, I promise you that. So here, what we need to worry about in our CMake list file, which I'm just going to load up right now. So I'm going to load up Sublime and load up the editor. So in here, you'll see the lines for CMake. I'm going to try my best to go through this, but to really understand this, again, this came from this tutorial using that hello world for CMake. Which one is it? This one? No. Yeah, it's this one. So again, it will walk you through the entire process on how I built out this CMake file. Okay. So understanding that, what we got here is we need to set up our initial required minimum version of CMake. And here, obviously, you don't need to worry about these hashtags. They're just comments. And here, what we're doing is, in this line, we have to set up and tell the compiler, in our case GCC, that we are using standard C++ version 11, which is a requirement for Redis. It's not using the standard, I believe it's 98, and we are specifically telling the compiler in the flags that we are needing version 11 support. Obviously, this is the project name is TBB Redis. Now, this is where it gets really maybe confusing for people. Here in this line, what we're going to do is we're going to set up where the project link library's path or directory will reside. And these are the expected files that we will have within that folder. So if I do a search on lib, the directory, you'll notice all of the libraries that I've just listed here are in that directory. Okay, and what I've done is here, when you compile out and build your libraries, you just manually move them into your lib directory. Okay, that's what I've done. Okay, that will make life a lot easier when you try to rerun the CMake file and build out the configuration for the make process. Okay, so those are how I built out my libraries for the C++, and that's for the linker. Okay, because there's two processes. Step one is you compile with the C++ source code, then you create basically object files, and those object files will then get linked with the libraries that I've just mentioned here, these ones. Okay, and that is again as part of the CMake or make process for linking your libraries. So that's what I'm referring to here, this line here, line 10. From there, what we've got to do is the next step is to tell Make and C++ or the GCC compiler where our include directories are. Now in C++, if I go to that path, okay, so if I go to the path include, let's see here. Oh, if I go to the include, you can see I'm in the include here now. One folder down. Now, if I do an ls, a list, you can see I including this header file HPP, or it could also be just .h. Redis. This is needed as a dependency in my source code when I include this file in my C++, which enables me to talk to the Redis library and external source files, or which are really the object files that get created, or actually get linked in from the Redis library. Okay, and I'm going to show you that code in a minute. So we need to tell the compiler where we find those include files. Basically, the include is really referencing the header files, the h.h or HPP files. Okay. So we include we mentioned where those include files are, and again, you'll notice here, any include files are external. You probably want to move them all into the include folder. Once again, this link here, this Derek Malloy, will explain this much better than I am in this video. So don't be daunted or scared off what I'm mentioning. You just got to kind of take the time to go through these links. From there, what we're doing is we need to basically build out or compile everything and link everything. But that's all done in the CMake file that I've got here. Okay, so what we've done already, we've included, told CMake where our libraries are. We've told CMake now where our include files shall be, or the path where they can find them, with the .h or .hpp files, also known as header files. So from there, we need to tell CMake where we're going to find all our source files, the CPP files. So here you can see that they're going to be included in the src or source folder. So let me just navigate to that folder. So again, we are in our main folder, the top levels, tbb-redis. If I do an ls, you can see we have a src folder. Let me just show you the detail of that. So here, the D refers to directory. X anytime means that that file is executable. I'll show you what I mean in a minute. So if you navigate to the source file, you'll notice here we have a source file, the lib-redis.cpp. That file is a walkthrough explained here using CMake as my IDE. All right, hopefully you're with me so far. If not, you can always rewatch all this stuff. So again, we've talked about the header files, specifically the redox header file, and obviously the libraries. And now we've got our src files mentioned here within the CMake text file, CMake list text file. So we're at this step right here where we're telling now CMake where we could find all the source files and C++ source files. And this tag will use all of what's available that has the extension of CPP. And again, this is better detailed in this posting right here. Okay, cool. All right, so now we start to get into the fun stuff. Here, what we're doing is there's two options here. We can create a library, or in our case, we want to create a executable, a program that we can run called tbb-redis. So how we're doing here in this statement is we are creating a file or an executable or a bin file, sometimes I call it if you're in Linux or Mac OS X, or an executable if you're in Windows, using all the source files that we've talked about found in that src folder here, okay? And then lastly, what we're telling CMake to do is to link our final executable file, this one, tbb-redis, with the libraries as I mentioned up here. And that's pretty well it. Hopefully you're with me so far and you're not confused. As I said, C++ is not a fun world sometimes, but necessary if you want to get the big dollars. But this is the starting point of how to build out C++ projects. Okay, so let's navigate here into the build file. So what you do is you'll download this project, and again, I'm only going to make this available for my Quant Elite members so they just understand how this works. So if you want to get this, just join my Quant Elite membership. So as I said, I'm going to navigate to the top level directory. Here we got our CMake list file, which is this right here. I'm explaining. But if we go back into our builds directory, this is what gets created. First thing we got to do is we need to run CMake dot dot. So we're now going to run CMake dot dot, which will process that CMake library, or sorry, CMake list text file. It'll process it at the parent folder level while you're in the build subdirectory, which is here. So basically what we're doing is running CMake dot dot, and then all the resulting files will get created in our build folder. So this is what will typically happen, but in this case we've got all our necessary files already created. What does get created is a CMake text file or CMake cache file. Don't worry about that. Some additional extra files. It will create our make file, which is important when we do our make. And it will create, as I said, the necessary executable here. And again, when you do this ls minus L, what will happen is it will list out the detail of all the permissioning on that file or folder. So in our case, what we got here is when we do a make, which I'll show you in a minute, the result will be it will create a library. Well, actually, it won't create the library, but what will happen is if we use this command right here, add underscore executable TBB, that gets created here, which is an executable, as you can see here. So if I run that, it won't run. Let me just see if I have Redis. It needs to be running. It won't run. It won't connect. So if I try to run this TBB Redis file, oh, it is running. So my Redis is running, Redis server. So it can run, no problem. So that's fine. That's all I want to show you. But if you ever decided to want to create a full library, you use this line. So that will create this library right here, lib tbb -redis .a, which is a static library. Okay, now if you want to understand what static libraries and dynamic libraries are, there's a pretty good explanation of it here. So in this example, if you want to build out a static library with a .a, that is explained. And then there's also this one of the, in this case, .so, but because we're on Mac, it will create a .dylib. Okay, before I show you, let me show you an example. So if we go back into our lib directory, what we get here is we'll get a bunch of static libraries here because you got the .a, and then in this case we have the TBB, which is a dynamic library. Okay, and again, if you want to know the difference, you're best off to read these examples here in this link here. Okay, so as I said, the first thing you do is, we've already covered it, when you're in the build directory. Oh, come on, build, there we go. Nope, okay, I'm gonna do it the lazy way with our tab. Nope. I can be, as I said, the world's worst typist, B-I-L-D. Let me just go up the lazy way. Okay, so if I do a list, there's our build. So if I do a build, boom, yay, fantastic. All right, so I mentioned when we do that CMake dot dot, you can see it will create a configuration file generating done, and guess what? It creates this make file. So you don't really have to worry about it, but I'll just show you that just for kicks. So if you edit it, you can see CMake will create this file for you. Okay. So you usually don't have to worry about it, but to process it, all you gotta do is just go make, and it will make everything for you. So let's say if I remove TBB Redis, let me just see here. Okay, I'm gonna remove RF TBB Redis. Oh, yeah, there we go. So I've removed the executable file tbb redis. So if I do another make, just gonna demonstrate the linking. There you go. There's our new tbb redis file. As usual, let me get rid of this sometimes annoying client of email. I'm going to shut that up. Alright, so that's created using that make for the files of tbb trying to make the executable, right? Which I have right here. So what I'm referring to is this line right here. So let's go into some other folders here. So I'm going to move up one directory back into the top level directory, do an ls. And let's see if I go to src. We have that. We've talked about the lib stuff and build. Now in there you may find a file called .o. Those are object files, and those are the object files of the src, of the C++ files. So sometimes you may find a corresponding .o file as part of the build process when it compiles. Okay, so that's pretty well what I wanted to show you regarding CMake and how it works with C++. So let's just do a quick recap here, because I know probably people are overwhelmed here. Alright, so we've got this playlist for the C++. I've talked about basically all the different historical videos you can watch pertaining to TBB, the Intel TBB for the multi-concurrency library. I've also mentioned about the Redis client in C++ called Redox, R-E-D-O-X. And what we want to do is basically build out those dependencies right here, and then that brings us using HiRedis, which you could show the instruction how to build it here, libev, instructions how to build that library locally from source, what I'm referring to. And then this will show you how to build out the Redox library as well, which is again the C++ Redis client. And then again, this is the C client for HiRedis. And then again, we need to worry about the TBB, which you can get the library here under this download directory, or sorry, this download link. From there, what we want to do is make sure that all those libraries that we mentioned here, the .a's, libev, libHiRedis, libRedox_static, and also your libtbb dynamic link library is put into your lib directory, this lib right here. Okay, so what I'm referring to again, just to make sure everyone understands, is we're referring to this folder right here, lib, and all those files, those libraries are included in this library. And then of course we need to worry about our header files, or the include path, which again, all we're really worrying about is this redox here, .h. So let me just load up that source code, or actually I can do it here. Okay, so let me just show you the include. Okay, so here we are now in the include subdirectory or folder. We have the Redox HPP header file or .h file. Okay, so let's take a look at the source file, just to make sure we understand that. Okay, so we're now in the source folder, which you see here. And let's take a look at what's in there. We've talked about this, the C++ file. So all I'm referring to really is the tbb redis.cpp. Okay, and when I'm saying header file, this is the only one, actually there's two, that we worry about is Redox and the tbb flow graph as well. So you need to include this tbb include folder as well. Okay, so we know everything works. Showed you that executable, and let me just go back into that file here for the CMake list text file. And again, we are talking about what I just said was the executable of TBB Redis. So I showed you that, which is again here under the build folder. There you go, right here. Okay, so when you do an ls and you get the make working, it should create that lib-redis executable file. As I said, when you do an ls -l, you know that'll be executable when you see that x as part of the permissioning at the end. All right, so that's it. As I said, this CMake file I'll make available for my Quant Elite members. I'll also make this project the project that I'm referring to for the TBB Redis as well available. And if you're on my email list, which I hope you are, let's see here, it takes a bit of time to load up in Xcode. The actual source code for this, we'll call it the actual source code for this, what I'll call roadmap of this program, where it merges both the libraries of both the TBB as well as the Redis that can be used to run your workers, which I would use to set up as, let's say, algorithms or indicators. And again, I've explained all that in this video here. Okay, so I'll make that ready, available, but you will need to be on my email list, because this project is only going to be up for a very, very short time. And when I'm saying this project here, so you can use this as your roadmap for your code, I'm only going to make this probably available for only 24 hours. It's what I'm going to consider a flash sale, and I want to make people aware of that, which is really important. I will most likely be doing a walkthrough of this live on a meetup probably next Monday, being July, let's see what date that would be. Alright, so that would be July 25th. So I'll do this live, the CMake and this project, the walkthrough of it, and I'll make it available around that time till Tuesday the 26th, a week today. So get ready for it, and I'm only going to do this once. And obviously, when I say is limited, I'm going to be moving into a new type of service, and I'm going to be getting out of this whole education on the technical front. But I just want to give anybody who's a real loyal fan of mine, and I appreciate that, and if you're a member of mine, that you get this code and you can use this for your C++ future trading system. Because as I said, right here, you can just set up these classes that I've set up here, or the structures, or however you want to do it, in C++, and use those algorithms as and run them in parallel using the Intel TBB. And again, all of that's explained here in this video. Okay, so I'm going to shut up now, make everything available probably come Monday, July 25th, 2016. And most likely this video may disappear, as well as this video as well after that date. All right, so hopefully you'll take advantage of it. If not, don't worry about it, and we leave it at that. All right, I'll talk to you later. If you got questions, you know where to reach me at. And if you are new to all this, just do a refresh. You come to my blog here under quantlabs.net/blog. I have my email list that you should be on. You just log in here, give me your name and email, and don't worry, I don't release that information to anybody, as well as if you are interested in getting the source code and the CMake file that I've just talked about, you can just come under here under Elite and sign up, and you're ready to go once those files become available. Okay, so hopefully this will be a big event on July 25th, okay? And you have the CMake files. You'll have the project ready to go. And if you have difficulties setting it up for your potential IDE using Visual Studio, in my case, the Mac OS X with Xcode, Eclipse CDT, or Kdevelop for Linux, these instructions will walk you through that once you get the CMake files, and you should be able to proceed with the source code as well as Redis and the Intel DVB, which is all free and open source. All right, so I'll talk to you guys later, and hopefully this will help you out later.